Hello, I'm Dave Barr, head of the School of Materials Engineering. On behalf of all the faculty and staff of the school, I'm pleased to virtually welcome our Materials Engineering alumni, students, faculty, staff, and friends to our 2021 Outstanding Materials Engineering Award. I hope that you and your loved ones are safe and well. While we wish we could be with you all in person, we also appreciate that many of you would be unable to travel to West Lafayette, so instead we are ever grateful that you can connect with us virtually for this very special event. The Outstanding Materials Engineering Award was established to annually recognize MSE alumni who have demonstrated exemplary accomplishments and leadership in some aspects of the field of materials engineering or an affiliated profession, and received their degrees more than 10 years ago. All awardees are nominated by either faculty or alumni and have been elected by a vote of the entire school's faculty. Since the school has more than 2,000 living alumni, we view this award as an important way to recognize our exceptional graduates. Without further ado, please allow me to introduce our first honoree, Dr. Matthew T. Cush. Cush serves as a Senior Technical Specialist in Materials at Rolls-Royce, where he has been instrumental in developing the company's capability in the field of single crystal casting and nickel-based superalloys, advanced manufacturing technologies, and high-temperature material development for hot section turbine components. He currently serves as the technical specialist for high-temperature turbine materials and manufacturing methods that focus on developing coatings for ceramic matrix composites, commonly known as CMC, including oxidation coatings, environmental barrier coatings, and abradable coatings for silicon carbide-based CMCs, and developing advanced materials and manufacturing methods for fabricating advanced cooled dual-wall turbine components. His work at Rolls-Royce has led to collaborations with Purdue faculty, including several graduate student research projects and sponsorship of senior design projects, where he is able to help expose students to the critical issues and advancements in the field of advanced turbine materials. Cush has been awarded 17 patents, with another 6 pending, and has published 6 papers in the peer-reviewed literature. For his technical expertise in developing advanced materials processing methods to create high-performance materials for extreme environments and turbine engine applications, the School of Materials Engineering is pleased to recognize Dr. Matthew T. Cush as an outstanding materials engineer.
Hello, my name is Matt Cush, and I live in Martinsville, Indiana, where I'm a senior materials engineer for Rolls-Royce North American Technologies in Indianapolis. I graduated from Purdue with a bachelor's in material science in 1992, and then went on to complete my PhD in material science at the University of Michigan in 1998. I'm humbled and honored to be one of the 3 chosen to receive the Outstanding Materials Engineering Award in 2021 for my work in developing advanced materials and material processing methods for extreme turbine engine applications. I would like to extend my gratitude to the materials department, especially Dr. Nick Chawla for nominating me, Dr. David Barr, head of the materials department, and Robin Jakes for her work behind the scenes, making this unique event go smoothly. Of course, none of this would have been possible without my parents' support, which provided me the opportunity to attend Purdue. My family has a long connection to Purdue. My wife is a 93 grad, her parents 1969 grads, my brother a 1999 grad, and I have a nephew there right now. Purdue has provided a wonderful foundation for all of us to pursue our own careers and aspirations. When I finally left the academic world 23 years ago, I joined Allison Engine Company located in Indianapolis, which was later acquired by Rolls-Royce. We provide power solutions to civil aviation, defense, naval, and energy markets. I joined as an experimental metallurgist developing advanced single crystal casting technologies. A few years later, I volunteered to help our production single crystal foundry solve a difficult scrap issue, and that volunteer opportunity became my life for the next 10 years, culminating in becoming the manager of the foundry and tripling the output under my watch. From there, I moved to our machining facility to lead our manufacturing engineering teams, which gave me technical oversight of every part we manufactured for our engines. This was an extremely important growth opportunity for me to see the connection between material and processing, as I oversaw the manufacturing of basically everything from the front of the engine to the back of the engine. From this experience, I transitioned to managing a pre-production facility where we were developing state-of-the-art manufacturing processes to advance turbine component technology. I then moved to lead a team for another emerging high temperature technology, ceramic matrix composites, where I was also responsible for developing environmental barrier coatings. Today, I reside in the Rolls-Royce Future Programs division. Up to this point, my roles have been focused on enhancing our existing products and processes to lower cost and improve fuel efficiency. Today, my experience and knowledge is leveraged to help bring new designs and solutions to market that will provide Purdue grads employment opportunities at Rolls-Royce for decades to come. There have been many people that have made an impact on my professional career, but I'd like to acknowledge 3 people in particular that have led me to where I am today. First, Dr. Keith Bowman, now Dean of College of Engineering and IT, the University of Maryland, Baltimore County. But back in the day, he was one of my toughest professors at Purdue with his strict attention to detail and thoroughness. I can remember thinking in more than one of his classes, why in the world would I ever need to know this? Well, Dr. Bowman, I can stand here today and honestly say I have needed to perform tensor transformations in my professional career at Rolls-Royce. But aside from that, Dr. Bowman provided me an opportunity that started me on my way. I had mentioned to him that I was thinking about applying to grad school, so he offered me a research internship my senior year to help me get a feel for what grad school would be like. This was my first foray into high temperature materials research. I can remember attending his research group meeting, which included his other grad students and postdocs, to present my initial project work, and was just floored, overwhelmed, intimidated, questioned on every detail. I wasn't sure what I'd got myself into. But fast forward a year, and I'm now in my first group meeting as a graduate student, and lo and behold, the same thing happens. Yet this time, due to my experience as a summer research intern in Dr. Bowman's group, I'm ready. I'm confident. I brought food. Anyway, Keith, thank you for helping me choose my own path. Second, Heidi Muller-Largent, a 1979 materials grad from Purdue. She was a mentor and confidant to me for many of my early years at Rolls-Royce while I was running the single crystal foundry. Quite frankly, she's forgotten more about superalloys than I'll ever know, but she taught me there is more to being a leader than technical know-how. She taught me that it was okay to just sit and listen. I didn't have to jump right in, didn't have to have an answer or an action or solve the problem, which many engineers want to jump right into. Sometimes just a little empathy with no judgment can go a long way to helping someone who comes to you for a chat. Heidi, thank you for caring and helping me during my first years at Rolls-Royce. My last Purdue connection I'd like to acknowledge is Dr. Mary Lee Gambo, 1982 MSc grad from Purdue and a former recipient of this award. As head of materials engineering at Rolls-Royce, she provided me another opportunity to broaden my knowledge by selecting me to manage the Composites Technology Center. In that role, I led the team developing ceramic matrix composite materials and coatings for our high temperature components. But more than just the opportunity she provided, she has the ability to listen and ask insightful questions whenever I need someone to bounce an idea off. Usually the banter ends up with me going, "Now, why didn't I think of that?" Mary Lee, thank you for all you've done for me and showing me that in materials, there's always more to learn. Finally, looking back at the list of former Outstanding Materials Engineering Award winners and my fellow recipients today, I am blown away that I am to be named to that list. I feel as if I am standing on the shoulders of giants. I am ever grateful for my Purdue experience and the foundation it has built for me. Thank you for this honor. Hail to old Purdue and boiler up.
Our next honoree is Ms. Tracy D. Lopes. In December 2020, Lopes took on the role of Head of Flexible Robotics at Johnson & Johnson, returning to the company where she began her professional career. At J&J, she is involved in technologies that impact many of the medical device companies. Prior to this position, she was the Vice President for Strategic and Service Marketing for Varian Medical Systems in Palo Alto, California, a company focused on cancer therapy. There, she supervised a $1.3 billion portfolio of products that addressed oncology and cancer treatment. Lopes holds 8 U.S. patents, 6 for surgical instruments using ultrasonic techniques, and 2 for bone anchoring devices. Her work has been focused on both the technical challenges in developing products for surgery and clinically relevant tools for doctors to improve patient treatment. She has been recognized as a voice in advocating for women in leadership roles in science and technology, having served on the advisory board of Frost & Sullivan, Inc., and spoken at the 2020 Watermark Conference for Women. Throughout her career, Lopes has used her engineering background to solve problems that impact patients during testing, surgery, and treatment while advancing products from creation to commercialization. In recognition of her combination of leadership within the healthcare industry and her technical achievements in advancing surgical tools using advanced materials, the School of Materials Engineering is honored to name Ms. Tracy D. Lopes as an outstanding materials engineer.
It's hard to understand how one choice can affect your path. I am so incredibly grateful for everything I have been able to do and the lives I have been able to impact by one choice, that choice of becoming a Boilermaker. It is such an honor to be back, at least virtually back, with everyone today at Purdue after way too many years. I would like to take a minute and thank the incredible faculty in the Materials Engineering Department. When I came to Purdue, I actually didn't want to be an engineer. In fact, I tried everything not to be. All it took, though, was one semester as a biology major for me to finally concede to the fact that I belonged in engineering. They were my people, my tribe. The green engineering paper alone sucked me in. How many late nights at the library and the union writing on that green paper? I felt like one problem could take hours, but thinking back, that one problem also connected me to my friends and helped me appreciate the team. I am incredibly grateful again to the MSD team for taking that chance on me and admitting me as a student in the School of Engineering. I will always treasure that. The professors and administration staff were always pushing us to find a way through a problem, to seek not only the answer, but really to treasure the journey. I would like to take this opportunity to thank everybody who made it possible for me to not only go to Purdue, but to keep finding my way in this world. A huge thank you to my mom and my brother and my dad, who is no longer with us, my wonderful aunts and grandparents and in-laws, and my husband and 4 boys who on a daily basis keep me grounded. There's nothing like working a full-time job and coming home to 4 kids to remind you what is truly important. I would never have gotten through those long, cold Indiana winters if it wasn't for some pretty amazing friends along the way. One special person I met on my first day in the dorm, she lived across the hall from me and has always been the best neighbor and friend. Thank you, Beth, for being my first friend on campus. When thinking about today and what this award means, I couldn't help but go back in time and reminisce a little bit. Now, I can't share all of those memories. Some are best kept tucked away in the vault. I mean, it was college after all. At the end of the day, I enjoyed my time at Purdue. I promise I didn't waste any of your investment, Mom. I didn't enjoy the week-long Grand Prix events. There's some Harry's on occasion, or the late night Tri-Chi. Oh, I hope that place is still there. It was so good. Also, let's just say the promise of Big Ten football did not disappoint. I can still hear that train whistle on Saturday mornings. It was so loud and so early. Even the late night study sessions preparing for Professor Crane and Bowen's classes. Bottom line, I am grateful for the foundation I gained from the MSc team. Without the deep emphasis on the practical problem solving, I don't think I would be where I am today. I learned to keep looking for different ways to solve the problem through the strong diversity in curriculum and the classes that were offered. Thank you, Purdue. I am incredibly grateful for that. In preparing for today, somebody asked me about my major career moments. And thinking about it, it's not just one, it's a million little moments, stories, and more importantly, the amazing people along the way. It's Jim who took a chance on me because I've kind of explained how a rubber band worked in my interview. It's the story of Evelyn, who gave a brand new engineer some amazing advice during her first year, and one I still hold on to today. It's Anne in Rochester, who I watched her stay true to her decisions. It's Joanne, Jennifer, and Linda, who held the line and gave me so much hope. It's Anne in California, who can make me laugh in some of the hardest situations. And it's the many others who I still have yet to meet. It's not just about the products you launched, it's about the lives you impact. There are humbling moments when you are in an HIV clinic in the African ghetto, helping to bring point of care technology directly to a patient. It's watching your dad's surgeon use products that you helped to manufacture. It's watching one of your closest colleagues have an emergency procedure and the doctor using several stents that you helped to develop. It's getting the chance to live in China for 3 years and start up an R&D center. It's seeing your name on a patent for the first time. Those are the career impacts that stand out to me. But for me, it has always been about the merger of my work and my personal life that is the most meaningful. I get to do what I love for the people that I love every single day. And it's that simple. My story's still unfolding. In fact, there's so many things, it's just so many ways it's just begun. And this is why I'm so honored to be a recipient of this award. I see it as a nod, a statement encouraging me that I'm on the right path. I see it as an important aspect of my present and future story. There's still several moments to have, several stories to still be told, and more importantly, more people to meet and more lives still to be touched. Thank you for the assurance and the affirmation that I'm doing the right thing with this honor. And boiler up.
Our final honoree is Dr. Peter C. Tortorici. Since 2016, he has served as both the Senior Engineering Technology Manager in Advanced Manufacturing Engineering and as a Technology Collaboration Leader for Medtronic, the world's largest medical device company. Tortorici oversees the technology laboratory system across the company and around the world that supports research, technology, and operations to develop new technologies and processes for implantable medical device manufacturing. His oversight directly affects patients who are currently participating in a cardiomyoplasty clinical trial. From the reliability of the electronics and pacemakers to the manufacturing aspects of implantables, he brings materials into devices that impact thousands of patients each year. Before his current role, Tortorici successfully led an effort to reinvent and transform the quality management system to a lean, effective, process-based system that meets federal guidelines. As so many of our alumni know, the regulatory environment for medical devices is crucial to new products. As a result of his leadership, this project was recognized with a corporate-wide Star of Excellence Award. In 2017, Tortorici was named a Medtronic Technical Fellow, a level of excellence reserved for 0.2% of the 90,000-person company. He has mentored several senior design projects, ensuring current students are familiar with the critical aspects of materials and implantable devices. Tortorici has published 8 papers in professional journals and has been awarded 2 patents. He was named to the Purdue Co-op Hall of Fame in 2019, and I'd like to note that he didn't co-op with Medtronic, showing the flexibility of an MSc background. For his leadership and technical achievements in materials reliability for implantable medical devices, the School of Materials Engineering is pleased to present the Outstanding Materials Engineer Award to Dr. Peter C. Tortorici. Okay, so I just would like to start off by thanking the School of Materials and Engineering for this really, truly wonderful award. I'm truly appreciative and appreciate the school for nominating and awarding this to me at this point in my career. How I ended up coming to Purdue as a student was a little bit different path. I didn't have a lot of connections to Purdue. I was good at math and science in school, in high school. And so that was kind of at the time they said, you know, maybe an engineering is a career you should think of. My father was a banker. My mother was a bookkeeper. He went to school in kind of a non-traditional way after coming back from Korea in the Korean War. And so I was the oldest, so I had to figure out the whole college and university dynamic and how it worked. We went to several different schools to look, and we ended up coming to Purdue. My mother liked Purdue because it was only a couple hours away from our home in Chicago. And we visited several times, and each time we visited, Purdue made us feel very comfortable and more than just kind of a number in the engineering school. And so I was lucky enough to get accepted, and we ended up at Purdue. I really didn't know what type of engineer I wanted to be. I looked at aerospace, I looked at electrical, I looked at mechanical, I looked at civil, and I wasn't really too sure of really what discipline I wanted to go into, but I kind of like the materials that those disciplines used. So it wasn't so much the airplanes as much as what the airplanes were made out of. And so my first semester freshman year, I got good enough grades to qualify for the cooperative education program, which then I needed to pick a major. So I went to the call out, and there were hundreds of other students there from all the different disciplines. And one of the things that the director of the program was mentioning was, you know, there's a lot of students from electrical, a lot of from aerospace, and there's really not a lot of jobs to compete for the number of students. I just so happened to be sitting next to one of the professors from materials engineering, Geraldine Best, and she mentioned to me, she leaned over and introduced herself, and she asked what a major I was thinking about. And I said, well, I've been looking around, I wasn't really sure, and material is something that appealed to me. And she mentioned to me, she says, you know, we have about 55 job openings, and there are only about 4 to 6 of you that are interested in materials engineering. And so right then I said, I'm a materials engineer. That's exactly what I want to do. And I fell into it. I'm so glad that I had that serendipity encounter with her because it really, truly has been a blessing to me as a profession that I've really, truly enjoyed over the last 30 years. The School of Materials Engineering is a fantastic school. And at the time, it was a very small school. And it still is relatively small compared to others, but at the time I only had about 9 students in my graduating class. So it was very nice in the sense that we were able to develop an intimate relationship with all the different students from seniors to sophomores in materials engineering. And we maintain those relationships today. And we've also maintained relationships with all the different professors that we've encountered at the time. So I've done projects with Dr. Dave Barr, who's the head of the department, and we've collaborated together on some projects in additive manufacturing. I've done some projects with Dr. Carol Handwerker on lead-free electronics, and our interests are shared. And not only with professors in the department, but other students that I've graduated with counted. So gentleman Michael Sandlin, who's a materials engineering graduate, is a co-worker of mine at Medtronic. We live about 4 or 5 miles apart, and we've been friends for 30 years. Dr. John Barnes is an additive manufacturing expert, and I've maintained collaborative relationships with him through the years, and in addition to others that I've run into through traveling around the world. And I truly appreciated the time and effort from developing those relationships, not just with the students, but with the professors. And Professor Dayananda was extremely instrumental in my thought process, and everything I've learned from him, I've kind of translated to my daily activities. And one of the strengths is his attention to detail in how I word and craft
my technical writings, and among the other scientific knowledge he imparted on me. So he's been really instrumental. I'm very thankful for him and being a part of my life and in my graduate studies, in addition to a lot of the other professors in the department. So with that, I'd like to again say thanks and go Purdue.
Thank you all for spending time with us this evening, and congratulations again to this year's outstanding materials engineers. As we like to say, you can't make it without materials, and I believe and hope you agree that our honorees tonight have reaffirmed the validity of that slogan. We hope to see many of you on campus in the coming months as we begin to loosen visitation restrictions. So if you're in town for a sporting event, business meeting, or just a visit, please stop by the Neil Armstrong Hall of Engineering to say hello. Thank you for tuning in. Have a wonderful evening, and hail Purdue.